In this question, you will use a historic method of calculating the cost of a barrel of wine to determine which shape of barrel gives the best value for money. In Austria in the 7th century, one method for measuring the volume of a barrel of wine and hence determining its cost was by inserting a straight stick into a hole in the side as shown in the following diagram and measuring the length as d. The longer the length, the greater the cost to the customer. Let SD be d meters and the cost be c gulden, the local currency, when the length of SD was 0.5. The cost was 0.80 gulden. Question A. Given that C was directly proportional to D, find an equation for C in terms of D, 3 marks. So, since C is directly proportional to D, the equation is C is some constant multiplied by D. Directly proportional, it means the greater D is, the greater the answer C is. If it would be that C is inversely proportional to D, the equation would be C is some constant divided by D. And this constant should be found, and it can be found just substituting these values for C and D. So 0.8 is K multiplied by 0.5, hence K is 0.8 divided by 0.5, which is 1.6, hence C is 1.6 D. A particular barrel of wine costs 0.96 gulden. Question B shows that D is 0.6. So it is given that C is 0.96 and just substituting it for C into our equation, we need to find D. D is 0.96 divided by 1.6, and just using a calculator, you can see that it's 0.6 as required. The next. This method of determining the cost was noticed by a mathematician, Kepler, who decided to try to calculate the dimensions of a barrel which would give the maximum volume of wine for a given length as d. Initially, he modeled the barrel as a cylinder with S at the midpoint of one side. He took the length of the cylinder as 2h meters and its radius as r meters, as shown in the following diagram of the cross-section. Question C. Find an expression for r squared in terms of d and h, 3 marks. So, since it's a cylinder, this angle is 90 degrees and this angle is a right angle triangle. And this length is it's 2r, and this length is just h because s is a midpoint. And hence, we can just use Pythagoras theorem, so that d squared is h squared plus 2r squared, d squared is h squared plus 4r squared, and just solve for r squared, and it's d squared minus h squared over 4. The next, let the volume of this barrel be v meters cubed. Question D shows that v is pi over 2 multiplied by d squared h minus h cubed, 2 marks. So we need volume of cylinder, and formula is given in a data booklet, and it's pi radius squared. Radius is r here, so pi radius squared multiplied by height. Height is 2h here, and substituting this for r squared, we get that it's pi d squared minus h squared divided by 4 and multiplied by 2h, which is pi over 2 d squared h minus h cubed as required. The remainder of this question considers the shape of barrel that gives the best value when d is 0.6. Question E. Use the formula from part D to find the volume of this barrel when h is 0.4. So you need just calculate volume for d is 0.6 and h is 0.4. So it becomes pi over 2. D squared is 0.36 times 0.4. minus 0.4 cubed, and it's this 0.126 to 3 significant figures meters cubed. The next, use differentiation to show that h is square root of 0.12 when dv over dh is 0. So we should consider derivative to be 0, and we need to solve for h. Derivative dv over dh becomes pi over 2, it's constant multiplied by a function, it's constant multiplied by the derivative, so it's pi over 2. You may expand, it doesn't matter. And you can see there is difference, and derivative of sum or difference is the sum or the difference of derivatives. So d squared h derivative with respect to h, d squared is constant multiplied by h, so it's constant multiplied by derivative of h with respect to h, it's 1, so it's d squared multiplied by 1, and d squared is 0.36 minus h cubed derivative is just 3h squared, and it should be 0, and it can be 0 only when 0.36 minus 3h squared is 0, hence h squared is what? 0.36 divided by 3, 0.12. In general, h is plus minus square root, but since h is greater than 0, h is only positive root. Because h is length, it cannot be negative. The next, given that this value of h maximizes the volume, find the largest possible volume of this barrel to max. And so we need to calculate v for this h and for this d. And just using a calculator, and it's this value 0.131 to 3 significant figures meters cubed. And I repeat because it will be required for the next question, that it's a maximum possible volume for the cylindrical barrel. The next, Kepler then considered a non-cylindrical barrel whose base and lid are circles with radius 0.2 meters and whose length is 0.8 meters. He modeled the curved surface of this barrel by rotating a quadratic curve ASB with equation y is ax squared plus bx plus c for x from 0 to 0.8 about the x-axis. The origin of the coordinate system is at the center one of the circular faces as shown in the following diagram. S is at the vertex of the quadratic curve and SD 0.6, so it's S is the vertex. Kepler wishes to find out if his barrel would give him more wine than any cylindrical barrel with D is 0.6. The coordinates of A and B are 0 and 0.2 and 0.8, 0.2 respectively. Question F. Find the equation of the quadratic curve ASB 6 marks. So since we know that 0 and 0.2 belongs to our curve, we can substitute 0 for x and 0.2 for y to get what? That y is equal to c, which is 0.2, so c is 0.2. So c is found. Then you may substitute coordinates for b, for x, for y, and get equation for a in terms of b or for b in terms of a, but I want to use coordinates of the vertex. X coordinate of a vertex, it's negative b over 2a. This formula is given in a data booklet, and since it's in the middle, its x coordinate is 0.4 and is equal to negative b over 2a, and hence I can get b in terms of a or a in terms of b. Let it be b which is what, negative 0.8a, and hence we get this equation in terms of a only. So it becomes what, ax squared minus 0.8a plus 0.2 ax squared minus 0.8 ax plus 0.2. Then we know the distance SD is 0.6 and coordinates of S is for x is 0.4. For y it's this expression when x is 0.4, because x lies on our curve. So you may use this expression directly for y, but we can find y firstly and then consider just point S and substitute in 0.4 for x and found y for y, and then we can find a. So let's consider distance SD, which is what, 0.6. And what is distance between 2 points? Formula is given in a data booklet, and it says that it's square root x2 minus x1 squared plus y2 minus y1 squared. Which point is the first, which is the second, it doesn't matter, and is 0.6. Without square root, you can see that it becomes squared, or just 0.36. And let's rewrite. So we consider coordinates of S 0.4 and y, and coordinates of D are what, 0 and negative 0.2. So without square root, x minus x, so 0.4 minus 0 squared, plus y minus negative, so plus 0.2 squared is 0.36. Then y plus 0.2 squared is 0.36 minus 0.16, which is 0.2. And something squared is 0.2. What does it mean? It means that y plus 0.2 is square root of 0.2, or y plus 0.2 is negative root. And y, it's y coordinate point S. S is above x-axis, so y coordinate is positive. So as y is greater than 0, you can see minus minus, definitely it's negative. So we need only this. Y is root minus 0.2. And it's 0.2. It's not the final answer, so let's keep it to be the exact. 2472, 2472, and so on. And hence coordinates of S become 0.4 and this y, and since S belongs to this curve, we can substitute for x for y to get that this 0.2472 and so on is equal to ax squared. It's 0.4 squared, which is 0.16, minus 0.8 times 0.4 is 0.32a plus 0.2, and you can see that it becomes negative 0.16a plus 0.2. Hence this answer minus 0.2 and then divided by negative 0.16, it becomes a becomes negative 295, 0.295 to 3 significant figures. Hence, the required equation becomes negative 0.295 x squared minus 0.8 a, so it's plus 0.236x and plus 0.2. The next question, G, shows that the volume of this barrel is greater than the maximum volume of any cylindrical barrel with D 0.6 remarks. So volume, and this barrel is what its volume of revolution. Formula is pi limits from 0 to 0.8 y squared dx, and we should find this volume just using a calculator, mass integral. Oh, actually pi, but let's then multiply by pi. 0 from 0 to 0.8 and squared. I will take 2 3 significant figures. You may take as exact. So it's negative 0.295 x squared plus 0.236x plus 0.2, and then 0.2 then squared dx, and then multiplied by pi, and then multiplied by pi, and it is equal to 0.135 to 3 significant figures, and the maximum volume for cylindrical shape is this. So since 0.135 is greater than 0.131, hence the volume is greater than for any cylinder cylindrical barrel. And the last question, state one assumption not already given that has been made in using these models to find the shape of the barrel that gives the best value. 1 mark, so it means just one reasonable answer. For example, that the barrel or the stick is constructed or has 0 thickness. 1 is enough, you know. Or for example that the stick is straight and flexible, or the hole has 0 dimensions, or okay, 0 diameter, or has no diameter. And that's all for this question.